Today we are doing 6.7, which is the last section in Chapter 6. It's entitled Proportions and Equations. Really what we're doing is the same thing we were doing yesterday with the tables and the sequences and patterns and things. We're just going to take it one step further and use those in equations. So today we're looking at section 6.7 entitled Proportions and Equations. So we're just going to go ahead and jump into some examples here, because there are no definitions or anything that we need, so we're just going to jump into an example. So example number 1 tells us this. They want us to write an equation to represent the input and output that we have in a table. So if I look at my input, which we're going to call x, and the output that I get. Remember, the last time we used input and output is when we did the function machine. So just like I said yesterday, this is kind of like that function machine. We're putting something into it, and we're figuring out how do we get it out. So my input was 1, 2, 3, 4, and 5. And the outputs are 9, 18, 27, 36, and 45. So I want to ask ourselves, what am I doing? What's the relationship here between all of these? Well, when we go from 1 to 1, we're adding 9 each time, right? We add 9, we add 9, we add 9. So what that tells me is the equation that we have, so remember yesterday we wrote this as the nth term. And we said, what do? Well, remember that number that you're adding every time is what you multiply by. So I transform that into 9 times n. Because when you think about this, 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4, so on and so forth. Well, now they want us to write an equation to represent all of this. So in order for us to do that, what we're doing is just essentially taking this and using the variables they gave us. We're going to say y is equal to 9 times x. And that's our equation. So that, what we were finding yesterday, we're just using that and making it into an equation now instead of leaving it in the table format. Let's go ahead and look at a different example. We're going to look at one that's actually more of a word problem, so we can get some real world values in here and kind of see how that works. Right, example number 2. So they tell us the cheerleaders are charging $7 per car wash. So if they wash your car, they're charging you $7. So the first question asks to make a table to represent the number of car washes and the money they've made. So part A, we want to make a table. So we have the cars washed, and the money earned. So if we wash one car, we make $7. If we wash 2 cars, we make $14. If we wash 3 cars, we make $21. So as you see, what are we doing here with each of these things? We're taking this number, and we're doing what with it? We're multiplying it by 7. Because there's $7 for every car that we're washing. So you take this and you multiply it by 7. So the next question says, write an equation to find the total amount earned for washing the cars. So part B here, they want us to write an equation. So to write an equation, what are we doing every time when we're adding that 7, or we're taking the cars washed and we're multiplying it by 7? So if I have cars washed will represent C, and the money we'll call M. So how much money are we going to make? Well, the amount of money we make is going to be 7 times the number of cars we washed. And that's the equation. Their last question for us, I'm going to write it up here, is if they wash 25 cars, how much money are they going to make? So we want to look at this and say, okay, we've made the table, we saw the relationship, we were multiplying by 7 each time, we're adding 7 here. We wrote the equation, so all we did was the number of cars we washed, we multiplied it by 7, so now I've got to use that equation. We have M is equal to 7 times 25, and that's going to end up being $175. So it's really not different than what we did with the function equation a long time ago, that function machine. We're doing some of that same thing, we're just with a very specific type. We're now calling these proportions, we're calling them patterns, the arithmetic sequences we've been using. We're just using different terminology with them. So let's go ahead and do one more example. This time they give us the table. So it says the cost of renting a jet ski at a local marina is shown in the table. They want us to write a sentence and an equation to describe the data, then find the total cost of renting a jet ski for 6 hours. So they give us a table that has the number of hours and the cost to rent. So I rent for 1 hour, it costs us $10. If I rent it for 2 hours, it costs us $20. If I rent it for 3 hours, it costs us $30. And if I rent it for 4 hours, it costs us $40. I'm sure many of you already see the pattern, but they want us to write an equation to represent this. So again, what am I doing every time? We're adding 10 each time, or you're taking the number of hours and you're multiplying it by 10. So what's my equation? When I do this, the equation, we're going to have the number of hours, which I'm going to call H, and the cost to rent, we're going to call C. So I want to know, what's my cost to rent based on the number of hours that we have? Well, what am I multiplying or adding to H? Well, I'm multiplying H by 10. If I have H is equal to 1, I multiply it by 10 to get 10. If H is 2, I multiply it by 10. So we're taking H and we're multiplying it by 10. So our equation is C is equal to 10H, because it's $10 for every hour. So now they want to know, how long is it going to take if H is equal to 6? They want to know 6 hours. Well, we plug it in. C is equal to 10 times 6. So the cost is $60. That's all that's to it. Alright, your homework tonight. Let's clear up a little space and write it down. Your homework that you'll work on tomorrow in class is going to be on page 352, and it's going to be number 7 through, we'll go 7 through 21. 7 through 21 all. So make sure to bring your books and things. Make sure to both turn in these notes and the homework that was due that we did in class today. Make sure that 6.6 homework, turning that in with your notes, because I need to be able to check both those things. If I can't check both, you're only getting half the credit, because the notes are 5 points, the homework is 5 points. So make sure you are doing both of those things and turning them in. Don't just do them, turn them in so I can give you credit for those things.